Hello again. This is Tim Kearns from the Great Lakes Observing System, and we're broadcasting to you live today for the NCAR missing plane search. This is a continuation of the efforts that started in 2024 regarding a plane that took off in 1968 with two pilots and a graduate student on board and disappeared over the waters of Lake Superior on the South Shore near Houghton, Michigan. Now, researchers from Michigan Technological University, along with a team of industry and academia and other partners, partially brought together through the Smart Ships Coalition, in addition to the Great Lakes Observing System, put together a mission in 2024 to go out and survey a large portion of the Great Lakes of Lake Superior to look for this plane. Now, there was lots of searches done, of course, in the late 60s and early 70s. Some debris washed ashore, but nothing was ever found. So in addition to providing closure for the families, of course, interest in documenting and preserving this kind of information and testing new equipment, there's a great deal of interest around doing this type of mission. Now, 45 square miles were surveyed last September. A lot of the data was processed by a large team of people, and a number of targets were identified. Now, I'm going to show you in a second what some of those targets may look like on the data itself. Now, the crew is back out on the water this week looking at those targets that were identified. So I'm just going to switch over to another screen here and show you what the data actually looks like. All right. So what we're looking at here, the colorful data, reds indicate shallower waters and darker colors, greens, yellows, and through the blues, shallow indicate deeper water. Now, if I zoom in, this is what's called the bathymetry data. Bathymetry is like what it looks like kind of if we were to drain the water. Now, typically when you see bathymetry, sometimes it has what we call a hill shade applied. And that's like a function that pretends to cast a shadow on it. But what I'm showing you here is relatively raw sort of post-processed data, which is just the model of what the data kind of looks like. Now, you might be wondering, well, what are all those lines on my screen? Well, those lines are probably glacial scars from when we had the ice ages and the icebergs were moving and scraping what is now the bottom of Lake Superior. Now, the bathymetry data is just depth data. So we've colored it here by depth. And I can zoom in a little bit and you can see that it's not super easy to tell what I'm looking at here. Now, there's another type of data that we collect as well called backscatter. And backscatter represents the roughness or the surface texture. Really, actually, what it's measuring is the intensity of the return. So don't forget, this is probably, or this is sonar data transmitted from the echo sounder, which is a special device or transducer mounted on the hull of the surface vehicle, the surface vessel, transmits the sound down to the bottom of the lake, measures the amount of time it takes to come back. But the other thing that it measures is the strength of that signal, and that strength is called backscatter. Now, the strength indicates different types of contact on the bottom. So let's say it's soft, sandy sediments and mud and stuff. That's going to absorb a lot of that sound and return less of the signal. It'll still return the signal indicating depth, but less of the signal gets returned, which indicates soft, sandy bottom. Now, imagine if that signal were to be reflected off, let's say, a giant piece of metal or a rock. Well, then the stronger signal gets returned, therefore indicating that something might be there. So I've got the backscatter turned on. Now it's a little hard to tell here, and I might have lost my, let me just look around. I'm looking on my map here to show you. There's my target. Now, it may not be able to be seen super easy on your screen, but hopefully you can. Now, right in the center here, I've got a little red polygon around a mark. And that mark is what we call a target. So we found a bunch of these, maybe 30 or 40 of these on the bottom of Lake Superior in the survey area. And as you can tell, it's really difficult to tell what that is, but we know it's something. And so that's what the crew is doing this week, to look for what are those things. They're going down, they're deploying high-resolution vehicles to go and have a look at these. Now, it's still too deep and too unsafe and too expensive to send divers down, so we can use remotely operated vehicles to find out what these things are. All right, now I'm just going to zoom out and show you in context what we're really talking about here. So Lake Superior is big, right? It's nearly 32,000 square kilometers. As I keep zooming out on my map, you're going to see there's the survey area. and the track lines. These are the transit lines moving back and forth from the survey area, which equated to almost 25 square miles themselves. Now, these are really important to do because it gives you opportunity to collect new data about the bottom of the lake, even while you're surveying a particular target area. But as I continue to zoom out, you can see Lake Superior is pretty big and the survey area is pretty small. In fact, it represents only 0.14% of the entire surface area of Lake Superior. So not a lot, but hey, every little bit counts. But it also gives you an indication of how hard it is to find things like missing planes and shipwrecks on the bottom of the lake, when the amount of time and planning and logistics and cost to go and do something like this. So I've got Travis White, researcher, lead researcher at Michigan Tech University, who's out in the field, not really in the field, who's out on the lake, but we call it in the field, with a team looking for some of these targets and surveying them. So let's cut over to Travis and see how they're doing today.
Hey, good afternoon, Tim.
Hi, Travis. It looks like you've got another spectacular day on Lake Superior. And although maybe your mission is a bit somber because you're looking for the remains of a missing plane, you've still got a beautiful day to do it. So I'm happy to see that.
Yeah, we're super fortunate. This weather is critical for the work we're doing. We need really good calm conditions in order to be able to operate the ROVs and the side scan sonars and the other instruments. So this is great. It's exactly what we're hoping for.
Fantastic. Now, this is day 3 that you've been out there. How many targets have you been investigating so far, or ground truthing, as we say? And what have you found in those targets so far?
Yeah, so out of all the targets that you shared on the map previously, you know, the 30, 40 plus targets we identified, we prioritized those as a group, everybody that was involved in this project from the get-go. And we looked at them together and prioritized things that we thought might be an unnatural, non-geological features. Of those, we flagged 16 targets, 7 of which we called a high priority target, and 9 of which we called a secondary priority target. And yesterday we ran side scan sonar with these excellent conditions. We were able to scan over every single target. And the way we did that is we dropped our towfish down to the bottom, and we kept it on an umbilical, a tether, an elevation of about 5 meters above the lake bed. And we towed it very slowly over each of these targets, the 16 targets. And we covered roughly the area the size of a football field around each of these targets that were flagged from the multi-beam sonar that we did last fall. So yesterday we were able to cover all 16 with the side scan. And today we're going back to 5 or maybe 6 of these targets with a ROV, which has a camera on a remotely operated vehicle that we can drop down, and we can navigate and traverse along the bottom of the lake and try to actually physically find and see through the HD camera lens what each of these targets are. The side scan sonar gave us a very good high resolution acoustic image of these targets. And we were able to characterize them in greater detail and say, you know, for example, from the multi-beam sonar, we could say there's something there. It's a bump on the bottom. It's a reflective return. From the side scan sonar, we're able to say there's a target there that's about 20 feet long. It's casting a shadow, meaning as the acoustics propagate through the water, it hits the target and it hits the lake bed around it. If the target is standing up like this, as the sonar goes out to the side and it hits that target, it creates a shadow behind that target where it's no longer getting the lake bed behind it. And through that information, we're actually able to take measurements on the computer in the data collection software and characterize these targets in terms of size and orientation. So yesterday we collected all that data. We looked at it last night and we said there's 5 or 6 of these that look potentially like something that we should take the extra time to put a camera on. So that's where we're at today.
Okay. And are you able to share with us any of the imagery that you got from that remotely operated vehicle with the camera, so viewers can see what it actually looks like down there?
Yeah, absolutely. I shared with Sam here this morning, and I believe you may have it queued up. Target, we call it target number 7. And it was a feature in the multi-beam data that had a reflective return. It doesn't look like much, but it was an anomaly relative to the area around it. And I shared a video that we just recorded this morning. This is an ROV video. So it's HD video coming from a small robotic vessel that is connected to the boat through a tether. And the screen you're seeing right here is an actual computer or a monitor. And this is a real-time HD video from the bottom of Lake Superior in over 200 feet. So as you can see, there's sort of a blue glow, but there's not much light at that depth. So these ROVs actually have their own lights that we can use to brighten and illuminate the area. But as you can see, when we pulled up along this target, we have a rough lat long, coordinates, and we position the boat over top of those coordinates. When we drop the ROV down to the lake bed, we need to actually maneuver it around and try to find this object. And we were very lucky in being able to find this object relatively effortlessly this morning because our coordinates were so good from the sonar data. And here we are just traversing along it. And you can see what this appears to be is a very large tree. All the branches have been broken off, and there's a root mass at one end of it. So when we first put eyes on this target this morning, it appeared almost like a wooden keel and ribs, like an old wooden type of vessel that was stuck in the bottom. So it really got our hopes up that maybe there was some sort of shipwreck here. But as it turns out, this is just a log. And the reality is that many of these targets we're going to be looking at, perhaps all of them, are going to be natural features of the lake bed.
Wow. Well, that's quite remarkable. Thanks for sharing that. I'm not a scientist or biologist or a treeologist, but I wonder how old that tree is. How long has it been down there? But
asking to think, it could be hundreds or thousands of years old. I mean, it's quite a large tree, as you can see by its diameter.
Yeah, well, that's wonderful. I did want to point out for anyone who's watching this live right now, you can post some comments there's a comment section that we will see in real time, and we'll try and get them answered for you in real time. Likewise, if you're watching this on YouTube after the fact, by all means, put the comments in, and someone from GLOS or MTU will get back to you with your questions, or will comment back on the YouTube video. So Travis, could you tell us then, I guess, are you able to say, I recognize it's sensitive, have you found anything that may be considered aircraft debris, and what are your next steps for today or tomorrow?
Yeah. So at this point, we're really narrowing down, from our wide area survey last fall to now, we're really narrowing down the prospects. And this is kind of a final effort that we refer to as target investigation, or also called ground truthing. So we're literally looking at every little prospect and either confirming that it's a natural part of the lake bed or that it's not a natural part of the lake bed. We've already looked at one today, so we are down to about 5 targets remaining, and we're going to try to hit them all today. So I think, to be realistic, our odds of one of these remaining 5 targets being an aircraft are very low. However, we're going to investigate every one and do our diligence. And that's really what this is about at this point, is being diligent so that we can essentially put a wrap onto this survey area and, say to the best of our instrumentation and our abilities and the snapshot in time, we do not believe the aircraft is here, or perhaps we find it still. But I think by the end of the next day or so here, we should be able to say, through our efforts, we either do or do not believe that the aircraft is in this search. We can't say 100% definitively. There's always the possibility that it wasn't detected by our instruments. But what we've found very incredible through this process is that we started with this very wide area survey, 45 square miles, and using that multi-beam sonar instrumentation on the surface of Lake Superior in several hundred feet of water, we identified targets on a map that appeared to be anomalous parts of the lake bed. Yesterday, we went to the football field scale and we looked at those targets again with a side scan sonar, so higher resolution instrument. And everywhere that we had a target flag from the multi-beam, yesterday we went over that with the side scan and we definitively found the target on the side scan sonar. We definitively found a target in each of those locations. And today, on the very first of those side scan sites, we identified the target with a camera. So really what's been surprising and amazing to us is that we've been able to use all of these different types of technology to definitively locate objects that are not that are anomalous to their surroundings. And it, for folks that don't understand the geology of Lake Superior, it's, for one, it's incredibly vast, but in terms of the lake bed, it's very it's not homogeneous, but the changes are very minimal across this landscape. It's almost like an underwater desert where you've got these hills and valleys and sand and rock. But the changes, amongst that substrate and lake bottom are very minimal. There's not a lot of anomalies there. There's no plants, there's no vegetation in this depth of water. There's maybe a few fish, but anything that is sitting on this lake bed should stand out to us. And we've confirmed that now with several different layers of instrumentation.
All right. Well, thanks very much, Travis. That's super interesting. I do have one question for you that many viewers might be interested in. What about invasive species? Are you seeing blankets of mussels and that sort of thing on the lake bed or on some of these targets you're finding?
We are not seeing any of that. So Lake Superior, we're fortunate, is very much intact relative to its native historical state. It has fewer of the invasive species that the lower lakes do, partly due to its location, being further north, further removed from the seaway, less trafficked. So the lower lakes, Michigan, Huron, et cetera, they have carpets of zebra mussels and quagga mussels. In Lake Superior, there are some mussels. However, there are very, very few. That's also partly due to the difference in water chemistry and the temperature as well. So we haven't seen anything anomalous or out of place to what we would consider natural and native state of the lake bed thus far. And I can say that confidently using this ROV. I'm just going to show you really quickly. I've got the ROV behind me here. So this is our ROV, and this is basically a small robotic vessel that we can send down. And on the front side of this ROV, we've got lights and we've got cameras. We've got a manipulator here where we can actually collect samples from the lake bed. So the tools we're using offer us a lot of fidelity with the approach we're taking, and I can pretty confidently say we haven't seen anything out of place.
Right. Oh, well, thanks very much for showing us all that stuff, and it's great that you've been out there again. I'm glad you had good weather, and glad that it's been a successful mission so far, and wish you the very best in the rest of it. I wonder what the next steps would be if you don't find anything. I know that we've got some analysis of the data that you have collected this week to still happen. But if we go on the assumption that you don't find anything that is identified as plane debris, then do you anticipate future surveys? What would that look like? Maybe where would you go? Would you want to expand the size of the search? And do you think there'd be interest from in having the public maybe fund some of the sponsors some of this to help pay for it? It's expensive to do this, I'm sure.
Yeah, well, that's a great question, Tim. Thank you for asking. I can say enthusiastically that if we don't find this plane today, this is something we want to continue to investigate. In terms of immediate next steps, our goal is to take this survey area and to be able to say that we do or do not believe there's something in it that is related to the plane. That's the ultimate goal. And I believe, at this point, we're several steps away from that, but getting close to that end. And what that means is once we've concluded this search area, we'll then be able to take the data that we've collected through this effort and make that available to the public interest. We'll be able to publish this data and work with GLOS and make sure that it's contributed to the Lakebed 2030 initiative. So this data has many uses beyond just looking for aircraft. As you mentioned, there's fisheries and habitats. There's natural features and geology here. So we hope that by publishing the data, there are folks out there who can use it for their own interests, whether it's recreational, just personal curiosity, perhaps for commercial navigation and safety. So there's a lot of benefits here to getting this information and making it available. So that will be the immediate next step, is to kind of put this search area to rest. And in terms of future next steps, what we would like to do is to continue to expand on this area And should there be funding and opportunity to do so, we would love to look at the next logical search area relative to this mystery, which would perhaps be further offshore or perhaps further to the south. We'll have to think about that. Working with Wayne and our state archaeologist and any other information that might come to light in the near future, so that we can put our efforts to good work. So I think in terms of cost, we're really talking about a crew and a vessel. We're talking about some equipment that we already have here available, but there are also some very expensive pieces of equipment that we don't have. Last year, during our fall survey with the multi-beam, we had excellent support from industry, from Norbit and Kongsberg. And should we continue this type of work, their partnership would be very important, providing access to that type of instrumentation. Those instruments alone might cost $300,000 or $400,000 for a full multi-beam sonar system. So if we were able to use that equipment, again, the costs of actually operating it are quite small and modest compared to the cost of purchasing it outright. So, in terms of what it would take to do a survey of the same scale, should we have a partnership from industry on some of the equipment time, we're talking maybe low six figures. We could get out here and spend another week on the water. We could collect that data and cover another 40, 50, maybe 100 miles of lake bed. So there would definitely be an opportunity to crowdfund some of this if there's interest. And I think that'd be an exciting conversation to have.
All right. Well, thanks, Travis. That would be great to have. And if you're out there watching this, or you're connected to the Great Lakes in any way, and you'd like to support the search for this plane or any other wrecks and Lakebed 2030, which is an initiative to survey the entirety of the Great Lakes in high resolution from shore to shore, by all means, get in touch. You can reach us at underwater@glos.org. We'd love to hear from you. You can also visit us at glos.org for our website and find out more about this program and some of the other programs that we do. GLOS exists to provide data and information to people just like you out there who have interest in it, whether that's lake floor data about missing planes and what it actually looks like down there, or maybe it's temperature, current, water, wave, weather, coastal safety, and maritime navigation and security. That's really what GLOS exists, is to provide data for the public. So thanks for joining us, Travis. It's been great to have you here this week. Safe voyage, and for the rest of your day out there and tomorrow as you demobilize the mission. We'll look forward to next steps. We'll look forward to more YouTube videos and updates on this mission and others. And if you've got any questions, by all means, reach out to us at GLOS or MTU, and we'll be able to answer them for you. Thanks again.
Yeah, thank you, Tim. We really appreciate you sharing our story here.
All right, that's great. Okay, bye for now. All right, that concludes the live stream. If you've got any questions, reach out to us at GLOS, underwater@glos.org, and we look forward to seeing you. We've got a whole series on what it takes to provide data in and around the Great Lakes. As we say at GLOS, we're always happy to provide fresh data for the fresh coast. So look forward to seeing you on future live streams or on our YouTube channel. Check us out on socials and LinkedIn. We also have a newsletter you can subscribe to. And of course, check out seagull.app. That's where you get real-time lake conditions 24/7, 365. Thanks again. We'll see you next time.
Hey, Tim, I wanted to jump in real quick and point out that we did have one question directed towards Wayne Lusardi, who is on board with Travis. So if we could bring them back in.
Excellent. Yeah, let's take the opportunity. If Travis is still there, we do have a question. Travis, the question is, the missing plane, there's Wayne, the missing plane was doing research and gathering information on water temperature and water radiation. Could you tell us how that was done?
Yeah. Well, what do you think, Wayne?
Yeah, so they had a scientist on board from the University of Wisconsin-Madison, Veliud Krishna Menon, and he was monitoring observation equipment that was installed on the fuselage of the aircraft and on the nose cone of the aircraft. And basically, it was taking temperature readings and looking at different levels of air temperature above the lake at near the lake surface, slightly above the lake surface, and then high above the lake surface, and trying to figure out the way in which light and heat reflects off the water surface.
In terms of altitude off the lake?
They were flying very low. I'm not sure exactly how low that was, what their minimal elevation or altitude was, but it was very low. Certainly below 1,000 feet.
All right. Okay. Well, I'm not going to presume what happened there, but interesting piece to the story and a great question from one of our viewers. So thanks, Debbie, for sharing that. And thanks, Wayne, for taking the time to answer that as we tag it on to the end of the live stream, which I'm glad we did. So thanks, Sam, for jumping in and reminding us of that.
You're welcome.
Yeah, thank you again. We really enjoyed the opportunity to share this with you.
Okay. All right. Cheers, guys. We'll see you next time. Okay, everybody, that's concludes the live stream again, officially this time, and I'm glad that we had the question. I don't see any other questions that have come in during the live stream, but if there's any new questions that came in, just feel free to reach out to us or post them on our YouTube channel, and we'll be sure to get them answered for you. We'll see you next time.